Hello, and welcome to a small discussion on how to calculate the probabilities related to the rolling of two dice. On a standard unbiased die, there are 6 faces, and on each of those faces, we have the numbers printed from 1 to 6. Since each of those faces has an equal chance of occurring because the die is unbiased, the probability of any of those faces is equal to 1 over 6. The question then arises, how would you handle if you have a pair of dice, two dice? What if the question says, find the probability of getting a particular sum or a particular product? Well, let's see how you can handle that particular situation with the help of an example. Let's look at example number 1. Two standard unbiased dice are rolled and the sum of the numbers obtained is calculated. Calculate the probability of obtaining a sum that is a prime number. So our job is to figure out the possible sums and then see how many of those are primes so that we can figure out the probability of getting a prime number. Remember, when you roll a die, the possible outcomes are 1, 2, 3, 4, 5, and 6. Because we are rolling two dice, the easy way of doing this would be to create a sample space. A sample space in this case, because each die has 6 possible outcomes, you would need to create a sample space which has 7 rows and 7 columns, something that looks similar to this. Now in the first row, you need to write down the possible outcomes for die 1 as 1, 2, 3, 4, 5, and 6. And in the first column, you can also write down the outcomes possible on die 2 again as 1, 2, 3, 4, 5, and 6. Now let's figure out the possible sums that we can get for this particular table. Let's say that on die 1 we get a 1 and die 2 we also get a 1. In that case, the sum that we get here will be equal to 2. If you get a 2 on die 1 and a 1 again on die 2, the sum here would be 3. Similarly, a 3 and a 1 will give you a 4 and a 1 will give you a 5 and a 1 will give you a 6, and a 6 and a 1 will give you 7. So our first row of outcomes is complete. Similarly, let's go to row 2 and write down the possible outcomes here. Those are going to be 3, 4, 5, 6, 7, and 8. In row 3, our outcomes will be 4, 5, 6, 7, 8, and 9. In row 4, we'll have 5, 6, 7, 8, 9, and 10. In row 5, we'll get 6, 7, 8, 9, 10, 11. And in the last row, we'll get 7, 8, 9, 10, 11, and 12. So the total possible outcomes in this case are going to be 6 times 6, which is equal to 36. Now let's do our probability calculation here. Remember, probability is always equal to the number of favorable outcomes divided by the total possible outcomes. In this case, we saw that the total possible outcomes were 36. So our denominator should be 36. In the numerator, we need to figure out the number of favorable outcomes. This question wanted us to figure out the probability that we get a sum which is a prime number. So if you look at the outcomes, the numbers written in the red, which of these are prime numbers? The prime numbers or the prime outcomes are 2, 3, 5, 7, and 11. Those are the only prime outcomes. So let's see how many times they occur. 2 occurs only once, 3 occurs twice, 5 occurs 4 times, 7 occurs 6 times, and 11 occurs twice. So we can just add them up to see how many times we get a prime outcome. So we have 2 occurring once, 3 occurring twice, 5 occurring 4 times, 7 occurring 6 times, and 11 occurring twice. When we add them up, we get a total of 15. So there are 15 prime outcomes. So that will be the numerator of our probability function. So the probability of getting a prime sum is going to be 15 out of 36. And if you simplify and reduce it, it reduces to 5 over 12. So therefore, the probability of getting a sum which is prime is going to be 5 over 12. I hope this example was clear to you. Now let's look at another example. Example 2. Two standard unbiased dice are rolled and the sum of the numbers obtained is calculated. Calculate the probability of obtaining a sum that is greater than 9. In this case, we are again rolling 2 dice and our job is to figure out the probability that we get a sum that is greater than 9. As we saw before, the numbers that you can get on a die are 1, 2, 3, 4, 5, and 6. Because of that, we need to create a sample space with 7 rows and 7 columns as we did in the previous example. So let's quickly do that. this is what our sample space would look like. I've already filled in the values possible for the sums of the numbers that you get on each phase. Again, we know that the total number of outcomes is going to be 36. The question says, what is the probability of getting a sum that is greater than 9? Remember, probability is equal to the number of favorable outcomes divided by the total possible outcomes. In this case, the total possible outcomes, as we saw earlier, was 36, so the denominator has to be 36. And the numerator, we need to put in the number of favorable outcomes. You want a sum that is greater than 9, which means that sum could be anything bigger than 9, like 10 or 11 or 12. So we have 10 here that occurs thrice, we have 11 here occurring twice, and we have 12 occurring only once. So the number of times we get favorable outcomes is going to be 3 plus 2 plus 1, which is equal to 6. So there are 6 favorable outcomes. That would be the numerator of our probability function. So the final answer will be 6 over 36, which reduces to 1 over 6. Hence, if you're rolling 2 dice and the question wants you to figure out anything related to their sums or products, one of the best things to do is to create a sample space so that you can figure out the answers quickly. I hope this explanation was clear to all of you, and I hope when you try out these questions, you'll be able to apply this method effectively. All the best.